Let's look at some common trends um, of oxidation states or oxidation numbers in some atoms. And these aren't necessarily more rules, more than kind of like some tips to help you remember some of the most common oxidation states. So number one, substances that are in their elemental form. So elemental substances always have an oxidation number of 0. So if you have a group of iron atoms, its oxidation state is 0. If you have hydrogen, even though hydrogen is a diatomic element, its oxidation state is always 0. Same thing with chlorine. It's a diatomic element, but its oxidation state is always 0. Or sodium, it's always 0. Then you could do this with every single element of the periodic table. Number two, a monoatomic ion, sorry, a monatomic ion's charge is its oxidation number. So if we have, say, the iron 2 cation, its charge is +2. Its oxidation number is +2. The sodium cation is +1. Its oxidation state is always +1. Or chloride. Chloride is always -1, always has a -1 charge, so its oxidation state is -1. Number three, the sum of oxidation numbers is equal to the molecule's charge. So for example, let's look at water. Notice the charge on water is 0. That's a neutral molecule. And so when I add up all the oxidation numbers, they need to add up to 0. Now I'll tell you, I'll go through this in a little bit, like how I know this, but for example, oxygen is -2, its oxidation number, and hydrogen here is +1. And since there are two of them, that's an overall oxidation number of +2 for the both. And that adds up to 0. Now, how about the nitrate ion? Again, just kind of go with me. Assume oxygen is -2 here. And I got 3 oxygens. For this to add up to -1, why is it adding up to -1? Because that's what the charge is on nitrate. Nitrogen must have a +5 oxidation state. Number 4, I'm going to kind of focus on some specific atoms here. Group 1 metals, I should say metal ions, always have an oxidation state of +1 because all the group 1 cations are always +1 charge. We could say the same thing for group 2 metal ions. The oxidation state is always +2. Oxygen is usually -2. Now, there's a couple exceptions to that you will see very rarely. Number one, um, when it's in a compound called a peroxide, so it's -1 in peroxides. So like the compound hydrogen peroxide, the oxygens there have a -1 um, oxidation state. But most of the time, like 99% of the time, you're going to see it as a -2. Another exception, which again, kind of rare, but you should know it, its oxidation number is positive when it's bonded to fluorine. since fluorine is more electronegative. So those are two rare exceptions, but I do want you to be aware of them. The next atom we'll look at is hydrogen. Hydrogen is +1 when it's bonded to nonmetals, and hydrogen is -1 when bonded to metals. So, for example, in CH4, each of those hydrogens is +1, has a +1 oxidation state. And then if we just kind of did the math, that would mean the carbon is +4. But in a compound like sodium hydride, if sodium is always +1, it's going to make that hydrogen be -1. And then finally, halogens, fluorine is always -1. It will never be any different. It's the most electronegative atom on the periodic table. The other halogens, chlorine, bromine, and iodine, are usually -1, except when it's bonded to a more electronegative atom. All right, so let's look at a couple quick examples, and this is something that you will need to do is I'll just give you a formula of something, and you should be able to tell what the oxidation state of the atoms are. So let's look at H2S, sulfite, and sodium sulfate. Okay, so here, H2S, notice hydrogen is bonded to a non-metal. So H is always +1, and I have two of them. So what does that mean for sulfur? What does sulfur have to be in order for this whole molecule to add up to 0? Sulfur has to be -2, because it all has to add up to the charge of the molecule. Now let's take a look at the oxygen here. Or I'm sorry, sulfite, SO3 2-. So we're going to assume oxygen is always -2 unless it's in a peroxide or attached to a more electronegative atom. And I have three of them. But I'm dealing with a polyatomic ion whose charge is -2. So it's got the oxidation states have to add up to that. So what does that mean sulfur is? Well, sulfur has to be +4. So oxygen is -2, sulfur is +4. Notice in this case, sulfur has a different oxidation state depending on the type of compound it's in. And then let's look at the last one. So let's start with sodium. Sodium is +1 always, and I have two of them there. Let's go to the oxygen. The oxygen is almost always -2, and I have four of them. And this is a neutral compound, so all the oxidation states should add up to 0. So what charge does this, or I'm sorry, what oxidation state does the sulfur have to have in order to um, um, have this all add up to 0? So in this case, it has to be +6. So sodium is +1, oxygen is -2, sulfur is +6. Again, I want to emphasize, notice how sulfur does not have a constant oxidation state.